Alright guys, so obviously I'm gone today. I'm going to go ahead and start with what we didn't get to all the way yesterday. Just make sure we get caught up on that stuff. We didn't quite get through everything yesterday, which you may have noticed when you started doing homework last night. But there isn't too much more, and I think we can clear things up. We're not going to check the homework today. I'll let you have the rest of the weekend to fix yesterday's homework and then to do today's also. So take a deep breath. No need to panic. We can get it done. Alright, so yesterday, this is one we did do. We're going to go through it again real quick. This is what we call a complex fraction. It's a fraction divided by another fraction. Okay, and since fractions are just division problems, we can go ahead and rewrite this laterally instead of stacked in another fraction. Okay, and we know that instead of dividing by a fraction, we can multiply by the reciprocal. So this fraction is going to stay the same. And we're going to multiply now instead of dividing. So that change is important. So we need to rotate this guy, and we're going to use the reciprocal instead. V cubed on top of 4t. When we multiply fractions, we can multiply straight across. Numerator times numerator, denominator times denominator. We have a couple choices, though. We can either reduce now or reduce after. If we're going to reduce now, let me see if I can just change colors here. Then we're going to notice that 4 and t have a common factor of 4. So if I divide both of those by 4, we'll get a 1 and a 2. And if I have a t squared up top and a t in the bottom, I can cancel those out as well, and this will just become a t to the first up here. Now I have a v down here, so v divided by v is 1. V cubed divided by v is v squared. So now when I multiply straight across, I will have 2t times v squared. So 2t times v squared all over 1 times 1. So we don't even have to write it as a fraction. That's just 2tv squared. Obviously much simpler than that guy. So that one we did do yesterday. What we didn't do were these two. We're going to skip those again. Complex fractions can also involve polynomials. So when we divide these two, we can actually divide a polynomial by a polynomial, and then that will allow us to move forward. So when I say polynomial, I mean a binomial or a trinomial, not just a monomial. So it can look something like this. So instead of freaking out, because I'm sure that's what a lot of people are doing, and this guy, we're going to notice that this is just one big fraction right here with two fractions on top. Again, just a complex fraction. So the first thing to do is rewrite it laterally so that we're not panicking. Okay, so we're going to write this fraction divided by the other one. Now we want to factor these right away. So let's go ahead and factor the one on the left. This pen's pretty fat. I'm going to make that smaller. Okay. So we have n and n. This is negative, so one of each, positive and negative. Factors of 18 that add up to 7. So we could do 2 and 9, a positive 9 and a negative 2. Down below we have n and n. This one's positive, so we're going to use 2 of the first sign, so 2 negatives. Factors of 1 that add up to 2 have to be 1 and 1. And we are going to multiply instead of divide, so let's make that change now. So we got to use the reciprocal of our second fraction, which would be n minus 1 over, and we need to factor this guy. Remember, this is a difference of squares. We've talked about this. It could be rewritten like this, if that helps. Factors of 81 that add up to 0 when one is positive, one is negative. So n plus and n minus, and they're both 9s because it's the square root of 81. Okay, so now's where we start looking for things that we can cancel. So I see an n plus 9 over here that also has one up here. Okay, there's n minus 1 down here. You could use either one of them with this guy. So we cannot get rid of this one, or this one, or this one. So we are going to have n minus 2 over n minus 1 and n minus 9. And then to multiply those back out, we would have n minus 2 over n squared minus 10n plus 9. Okay. Again, way easier to look at and understand than that Big guy right there. So just because it looks scary from the beginning doesn't mean it has to be. I would suggest anytime you see a complex fraction, rewrite it immediately as kind of a lateral division statement, and that will help remind you that you just need to multiply by the reciprocal instead of trying to divide. Okay, today's stuff. So we're going to work on actually dividing polynomials by polynomials. So when we're looking at something like this, rather than thinking about complex fractions or multiplying by reciprocals or anything like that, we're actually going to divide them. Step one is to write it as a fraction. I've got 2x squared plus 16x, and we're going to divide that by 2x. What I want to do is to divide each term by 2x, not the whole thing entirely. We're going to look at it piece by piece. So what we're going to do is rewrite it as 2x squared divided by 2x plus 16x divided by 2x. Just break this into two separate fractions using that guy, because it can be this divided by 2x and this divided by 2x. We can write them as separate fractions. And if you think about it in reverse, when we're adding fractions that have a common denominator, we just add the numerators, so you can see how we would be back up to the beginning there. Okay, so we're going to divide out our common factors. So let me rewrite this here, and then I'm going to change colors so you can see what I'm talking about. We want to look for those factors that are the same in the numerator and the denominator. So I see 2 over 2. We don't need that. X squared over x is just going to be x to the first. 16 over 2 becomes 8, and x over x gets canceled. So really all that's left in this guy is this x to the first right here. All that's left on the other one is 8. So all we have is x plus 8. So if we go back up to the top and we want to divide this thing by this guy, we're just going to get x plus 8. And we can prove that that works. When we divide 8 by 4, we get 2. And we can prove that by taking the answer, multiplying by the divisor, and getting back to our original value. So I'm going to do the same thing here. Take our answer, multiply by our divisor, and we will be back to 2x squared plus 16x. That's how you can check your answer. Okay? So the first step is to write it as a fraction. Then you want to divide each term by the divisor, basically break that fraction into two different fractions. Divide out the common factors. We're just reducing. Look for the things that can be divided out of each fraction, and then simplify it. Pick out the parts that you didn't eliminate and rewrite it. And then to check it, multiply that by your original divisor, and you should end up with what you started with. Let's do it again. Same process, different question. Okay, so we're starting with b squared plus 12b minus 14. We are going to write that as a fraction for step 1. b squared plus 12b minus 14, all divided by 3b. Then we're going to break it into 3 individual fractions so we can divide one term at a time. Because they all have the same denominator, we can do this. It's like adding fractions in reverse, right? We took a simplified fraction, put it into several fractions that have common denominator. Okay, so we're going to divide out common factors one at a time, looking for the things that are in both the numerator and the denominator. Let me change my color again. Okay, so I've got a b squared on top and a b in the bottom. Let me rewrite it and do it down here. I should not have changed colors. Okay, so I'm going to take out one of these b's and cancel it with that guy. I can't do anything with the 1 and the 3, so that's going to have to stay 1/3. Now over here, b and b are just going to go away. If you divide b by itself, you get 1. I have 12 divided by 3, which will just be 4. Now over here I have 14 over 3. I can't reduce that. and I have a b in the denominator. Well, there's nowhere for that b to go, so that term has to stay the way it is. So when we go to simplify this, we are going to have b on the top of the first one divided by 3. Then we're going to have just a 4 from the second term minus 14 over 3b. Not pretty, and I can't reduce that. These are not common. They don't have common denominators, so they can't be combined. That's as far as we can go there. That's as divided as it's going to get. Okay, if we wanted to check that, we can take what we have there and multiply it by our divisor, which if we look back at the top was 3b. Okay, so we're going to multiply this by 3b. The 3's here are going to cancel, so I'm going to have b times b, which is b squared. 3b times 4 is going to become 12b. 3 times 4, and then b. 3b, this whole 3b and this 3b will cancel, and we'll just have minus 14. b squared plus 12b minus 14. If we go back to the top, b squared, oops, too far. b squared plus 12b minus 14, which is what we ended up with. Yeah. So it all works out the same way. However, sometimes, well, let's do this one first. Go ahead and take this guy, split it into a fraction, write each fraction separately, take out your common factors, reduce each fraction, and then simplify. So go ahead and pause the video for a couple minutes until everybody's done, or at least close to done, and then I'm going to do this guy. Okay, hopefully everybody had a chance to get this one done. Let's get set here. All right, so we want to write this as a fraction. 4r to the 6th plus 3r to the 4th minus 2r squared all over 2r. We want to split that into individual fractions. 4r to the 6th over 2r plus 3r to the 4th over 2r minus 2r squared over 2r. We're going to start looking for our common factors. What's in the numerator and denominator that we can take out at the same time? Well, 4 divided by 2 is 2. R to the 6th divided by r will be r to the 5th. 3 over 2, can't do anything with that, but I can take this r out and make this r to the 3rd. Remember, we're just subtracting powers because we're dividing exponents. 2 over 2 just becomes 1. R squared over r is just going to be r to the 1st up top. So now when I rewrite this, I see a 2 r to the 5th on top, nothing on the bottom, plus 3r to the 3rd over 2. 3r to the 3rd over 2 minus, I only have an r on top and nothing on the bottom. And that's where we're at. Then if we want to check that, just like we did on the last one, we go back to it and we're going to multiply this by our original divisor, this guy, 2r. So each term gets multiplied by 2r. 2 times 2 is 4. R times r to the 5th is r to the 6th. Then this guy, we just did this one, so let's go to the second term. The 2 is going to cancel with the 2 in the denominator, which means we're just going to have 3. R to the 3rd times r becomes r to the 4th. Then when we take this to our third term, 2r times negative r will be negative 2r squared, which is exactly what we had to begin with. So we got it right. So you can always check just by multiplying it back through if you think maybe that doesn't look right. Not a bad idea to just get in the habit of doing. Okay. We can also divide by other binomials, though. Not always just monomials. The steps remain the same. H squared plus 9h, not an n, h, plus 18. Write it as a fraction, so we're going to put h plus 6 in the denominator. Now I cannot divide each of these by h plus 6. It's not going to work. So I need to factor the top. Everybody's favorite. So the top is going to become h and h. They're both positive. They're going to have to be h plus 3 and h plus 6, I believe. 3 plus 6 is 9. 3 times 6 is 18. And then we have an h plus 6 in the bottom. And if you check this out, these two are exactly the same. They can just be canceled. So we'll end up with just a total h plus 3. So that one worked out pretty well. And then again, to check it, take that h plus 3 that was our answer and multiply it by our divisor, h plus 6. So h times h is h squared. H times 6 is 6h. 3 times h is 3h. 3 times 6, oops, down here, is 18. Then when I add these together, I get h squared. 6h plus 3h is 9h. And then our 18, which is exactly where we started. Okay, so again, not a huge problem. We're just going to factor, look for the binomials that'll cancel, and then we're done. Sometimes, though, we can't factor. Or, once you factor, there are no common factors. So let's go ahead and try and factor this guy real quick, just to see if it works. Factors of 12 that add up to 4. So the factors of 12 are 1 and 12, 2 and 6, or 3 and 4. But they both have to be positive. There's no way to add up any of these and get 4, is there? So we're going to have to do something different. Let's do this. Okay, can't be divided, or can't be factored, excuse me. So we're going to have to try something different. We're going to use long division. Now it's just like the long division you did in 3rd grade, where we write out y plus 3, y squared plus 4y plus 12. Okay, so we're going to look at this guy. This is going to be what our indicator is. So let me change colors here so that we can keep track of what we're doing. Okay, so what do we have to multiply y by to get y squared? Well, we'd have to multiply by y. So we're going to go back through. Can I change it right here? Yes. Sweet. We're going to go back through and multiply y times this guy. Oops, nope. That didn't work. Okay, sorry about that. So we're going to multiply by this guy. So y times y is y squared. Y times 3 is 3y. Just like the other long division, we're going to subtract. Y squared minus y squared is 0. 4y minus 3y is just y. And we do it again. What do I have to multiply y by to get y? Well, I'd have to multiply by a positive 1. So we multiply this by this guy. 1 times y is y, and 1 times 3 is 3. We bring down this guy and subtract. Y minus y is 0. 12 minus 3 is 9. Now here's where we run into issues, though. Y cannot go into 9. I can't multiply y by anything and get 9. So 9 is our remainder. So the way we're going to write that is the answer is going to be y plus 1, which is up here, plus 9 divided by y plus 3, that piece that we couldn't do. Okay, so this will be our quotient, and this is our remainder, the piece left over that we couldn't divide evenly. And since we don't have any skills to divide 9 by a binomial, we just leave it like that. So our first goal, I'm going to go back a second. Our first goal is to always do it like this, because factoring and then just canceling out the common factors is much simpler. But if we can't factor, or once we factor, if there are no common factors, nothing to cancel out, then we do have to go through and use long division. It doesn't have to be a difficult process, and what might be helpful is to go through and do a couple long division problems just with numbers. Remind yourself how the system works. But once you get it, it's really no more difficult than by factoring. Let's do another one. Okay, same thing. If you guys feel like you want to tackle one, go ahead and pause it and try it. Otherwise, just go ahead and watch, and I'm going to do this guy. First step is to get it set up for long division. Okay. So, what do I have to multiply n by to get n squared? Well, I'd have to multiply by an n. So then I'm going to go back and I'm going to multiply the entire binomial by n. So n times n, n squared. Negative 2 times n, negative 2n. So I'm going to subtract. I'm going to subtract what I just got from what I have. N squared minus n squared is 0. 6n minus negative 2n. I'm double negative there. 6 minus a negative. I'm going to add. I'll get 8n. Positive 8n. I have to look at what would I have to divide my first n by here, by my divisor. What would I have to multiply that by to get 8n? I'd have to multiply by 8. So I'm going to add an 8 up top. I'm going to go back and multiply it out. 8 times n. Well, before I do that, let's bring down our 2 here. There we go. Now I'm going to multiply by 8. N times 8 is 8n. N times negative 2, negative 16. Okay. Subtract. 8n minus 8n, 0, n. 2 minus negative 16, that's 2 plus 16, so positive 18. Now, is there anything that I can multiply n by to get 18? No, I can't multiply a variable by something and get 18. So that's going to be our remainder. That's a leftover. So our answer, our solution, our quotient, that's t, is n plus 8. That's the part we could divide evenly, plus this 18 that still needs to be divided by n minus 2 somehow. But we just are not able to do that. So we have the part that divided evenly and our remainder. A word you guys probably haven't used since 4th or 5th grade, but it's still around. Okay, so again, one step at a time, just like long division of big numbers, it works exactly the same way. When you get to the end and you can't do it anymore, that's your remainder, and we just leave it almost like we're saying, hey, I couldn't divide this. Here's the extra piece. Somebody else might be able to figure it out. In this case, that's not true, but the idea is this is the piece that remained that after I divided things evenly, it wouldn't fit, so that's the leftovers. Okay, you guys try this one. Pause it for a couple seconds. We'll make this one a yo-yo. Okay, give it a shot, maybe 2 minutes or so, or until everybody's ready, and then go ahead and hit play, and I'll go through it. Okay, I hope everybody has what they think is right anyway. The issue here is we're missing c squared, right? So we're going to fill that in as 0c squared plus 5c minus 6. If you didn't put a 0c squared, it's possible you did just fine. Let's just wait and see. Okay, so c minus 1. What do I have to multiply c by to get c cubed? I have to multiply by c squared. Let's multiply it back through. C squared times c, c cubed. C squared times 1, negative 1c squared. Subtract that. C cubed minus c cubed is 0c cubed. 0c squared minus a negative c squared means I'm adding c squared. So I just have a positive 1c squared. Let's bring down our 5c. That's positive. What do I have to multiply c squared? What do I have to multiply c by to get c squared, the new value I'm trying to reach? I have to multiply by a positive c. So now I'm going to multiply that back through. C times c, c squared. C times negative 1, negative c. Okay, we're subtracting that again. I suggest these parentheses. It'll help you with these double negatives to not just go, oh, 5 minus c, that's 4c, because that's not correct. We're actually subtracting a negative, which is going to actually add to it. C squared minus c squared still 0. I'll write it just in case. 5c minus negative c is 5 plus c. That's a positive 6c. We're back over here. What would I have to multiply c by to get 6c? I'd have to multiply by 6, multiply it back through. 6 times c is 6c. We're going to bring this guy all the way down here now. It's a minus 6. I could have done that before. I always forget. Oops, a little too far. We're multiplying by 6. So 6 times negative 1 is a negative 6. So I go to subtract this. 6c minus 6c is 0c. Negative 6 minus negative 6 is negative 6 plus 6, also 0. So we don't have a remainder. So our quotient, this is the answer, what we're looking for here. Why does that stop working? Our quotient is that c squared plus c, what the heck, sorry guys. C squared plus c plus 6. There is no remainder on this guy. Sometimes it'll work out. What that tells us is if we knew how to factor these cubic expressions, if I knew how to factor this, it could have just divided out. We could have done it without long division. Unfortunately, we don't know how to factor cubes yet. So we can't do it that way. We're just not able to. So we have to go through this method. And then it turns out that it would have worked anyway. There was no remainder. Okay. That's it. Homework is day 6. You have the weekend to also finish up day 5 if you were confused. We will go over this stuff again on Monday. We will have a quiz, it looks like, on Tuesday. If this is day 6, Monday we're going to do 11.6 and 11.7, adding and subtracting rational expressions, and we'll quiz on Tuesday. But I'll make sure that we have enough time to review and go over this stuff again. I know it's hard to get through this when you can't ask questions. The other thing I would suggest you do is check out the Khan Academy videos for 11.5. You can either search on Google dividing polynomials 11.5. You can watch Khan Academy. There are other videos out there too. I think Khan Academies are the best, but these notes are also posted online already on my website, so you have plenty of resources. But don't panic. We'll go through it again on Monday, and I'll answer you guys' questions. Have a great weekend.